Okay, this lesson is over graphing lines, okay, that are in a different form than you guys are used to. Okay, they're called standard form. Okay, so all this year you've been working with slope intercept form. So real briefly here's a equation in slope intercept form. Y equals 2/3 x plus 1. Okay, if I wanted to graph that, you guys are experts at this. You would take the 2/3 slope and the y-intercept 1 and use that to graph the line. Okay, you could find the y-intercept 1 first on the y-axis. Okay, then you would use the slope 2/3 to travel from that y-intercept of 1 to go up 2 over 3. Okay, you've been doing that all year, basically. Try to draw a line through those 2 points. Well, close enough. Okay, so to graph slope intercept form, you start with the y-intercept and use the slope to go to another point. Okay, but today we're going to look at standard form. Okay, standard form is a different form of a line. Okay, it's still a line, it's just a different form. Okay, here's some examples. 3x plus 5y equals 20. 4x minus 2y equals 10. Okay, 2x equals 8, 9y equals 20. Okay, these are lines. Okay, they are lines. They do make a line when you graph them, but they're just in a different form. And the way you want to think about it, it's something x plus something y equals something. Okay, where those three somethings, okay, call them A, B, and C, they're integers. Okay, no fractions, no decimals. And usually we say A can't be negative, although you're going to see the value of A being negative sometimes. Usually you don't want that to happen, though. Okay, let's just look at an example. Okay, 2x plus 4y equals 12. Okay, this is a line, but it's in a different form than you're used to. Okay, 2x plus 3y equals 12. You want to think about just finding solutions. You want to think about what could I put in for x and y to make this a true statement. Okay, and there's oodles and there's infinitely an infinite number of solutions to this. Let's just play with some. Okay, we're going to do this as a class, and we're going to spend more time on this as a class. Okay, but for example, I could let x be 3, and I could let y be 2, and I know this is a solution, okay, because 2 times 3 is 6, and 3 times 2 is 6, and when I add 6 plus 6, I get 12. Okay, that's a solution, 3, 2. So I can actually graph 0.3, 2. X is 3, y is 2. Okay, I can come up with another solution. Maybe let x be 0, and y could be 4. Okay, because 2 times 0 is 0, 3 times 4 is 12, and if I take 0 plus 12, I get 12. Okay, so 0, 4 is a solution. X is 0, y is 4, so I can graph that. Okay, I can find gobs of others. I'm just going to put 0 in for y. Okay, 3 times 0 is 0. And I know that if I add to 0, if I added to that 2 times 6, which is 12, okay, that would work. Okay, 2 times 6 is 12, plus 3 times 0 is 0. 12 plus 0 is 12. So 0.6 comma 0 works. Okay, so there's there's an infinite number of points that work, but these are 3 good ones. So I could just draw a line through those points. And what we're going to kind of focus on. Okay, you only need 2 points to have the line. Okay, you only have to have 2 points. And I wanted you to see that using 0, was an easy way to find two sets of points, two sets of coordinates that would work. Letting x be 0, figuring out what y has to be, setting y equal to 0, figuring out what x has to be. So what you basically could do, just to keep it more systematic, is if I wanted to graph a line, I could put 0 in for x, figure out what y has to be, put 0 in for y, figure out what x has to be, and plot those 2 points. Now, when you put 0 in for x and you find what y is, you're going to get a point like 0, 3. Okay, that's always going to be the x-intercept. Okay, there's point 0. You know what? They made a mistake there, didn't they? Okay, anyway, 0, this is going to give you the intercepts. Okay, when you put 0 in for x, okay, you're going to get a y-intercept. When you put 0 in for y, you're going to get an x-intercept. Okay, there's some mistakes on this slide, so I'm going to let's just ignore that for now, okay? I'm going to take that off actually. Okay, let's just go do a different problem. If I wanted to graph 4 times x plus 10 times y equals 20, and I wanted to do it kind of a quick way, I could put x in for 0 to find the y-intercept. I could put y in for 0 in for y to find the x-intercept. Okay, let's work through this one. Okay, I'm going to set x equal to 0. I'm going to copy down my equation. I'm going to put 0 in for x. I'm going to get 4 times 0, 10 times y equals 20. Okay, now if I do that, notice that 4 times 0 is 0. I can just kind of mark that out. I want to ignore that. So really all I have when I simplify now is 10y equaling 20. And I can solve that equation for y. So I can get rid of the multiplied 10 by dividing by 10. I end up with y equals 2. Okay, so I set x equal to 0. I ended up with y equaling 2. So if I put those two numbers together as a set of coordinates, the x coordinate goes first, the 0 goes first, the 2 goes next. There's 0.02. A 0.02 would be on the y-axis. Okay, so there's 1 point on my line, 0, 2. Okay, now I'm going to take that same equation, and I'm going to put 0 in for y. I'm going to put 0 in for y. 0 is an easy number to work with, so I'm just going to use 0 twice. So I'm going to copy my original equation, 4x plus 10y equals 20, and I'm going to replace y with 0 this time instead of x. Too many spaces or you're going to lose your text box. Okay, 10 times 0 just kind of goes away. 10 times 0 is 0. Okay, so what we're left with now is 4x equaling 20. Okay, and I can solve for x equals 20. I can get rid of the multiplied 4 by dividing each side by 4, and I get x equals 5. So I put 0 in for y. I came up with x equaling 5. Okay, so my solution, just put the x coordinate first. 5 goes first in my parentheses, and then 0 goes next. Okay, my second solution is 0.50. Okay, and there's 0.50 right there, and it's going to be on the x-axis. Okay, so what we're doing is we found the y-intercept and the x-intercept by using 0 twice. When we put 0 in for x, we end up with the y-intercept. When we put 0 in for y, we end up with an x-intercept. It's just a quick, easy way to find two easy solutions to these types of problems. Okay, so there would be our line. Okay, I will have the solutions to these available, but please let me, for the rest of the slides, but please let me know if you're having any trouble understanding this at all, and I'll help you out.